Sequences in Series, lesson number 3, Arithmetic Growth and Decay. In this lesson, we're going to look at generating number patterns exhibiting arithmetic growth. So many real-life scenarios can be represented by a pattern of numbers which exhibit arithmetic growth. For example, number 1, BP Birthplace Forest program in Calgary enables parents to honor their children by planting a tree when their child is born. At the same time, this shows concern for the urban environment by encouraging the growth of city forests. Some of the trees which have been planted are evergreen trees which grow an average of 12 to 18 inches per year. The program was launched in the year 2000. Part A asks us, so an evergreen tree 6 inches high was planted in June 2000 and has a growth rate of 15 inches per year. 2 students were asked to determine the height of the tree in June 2011. Joel formed an arithmetic sequence beginning 6, 21, 36, and Jenna formed an arithmetic sequence beginning with 21, 36, 51. Use the formulas in the previous lesson to determine each student's answer to the problem. So let's just write down what we know first of all. With Joel, we know that his first term is going to be A, which is 6, or you can call it T1 if you'd like. The common difference is 15 because the tree grows 15 inches per year on average, and N will be 12 because from June 2000 until June 2011, that is 12 years. So Tn equals A plus D times N minus 1. Plugging in my numbers gives me T12, so term 12 equals A, which is 6, plus D, which is 15, times N, which is 12 minus 1. So plugging that into my calculator, that gives me 171 inches. Jenna, on the other hand, starts her sequence with 21. So her first value is 21. The common difference, again, is still 15 because it still grows 15 inches per year. And N is 11 because from June 2001 to 2011 is 11 years. Okay, so if I plug that into my formula, Tn equals A plus D times N minus 1, T11, 11th term, is equal to 21 plus the common difference of 15 times 11 minus 1. And again, if I plug that into my calculator, it gives me 171 inches, the same as what Joel calculated. Part B says, determine the formula for the general term of Joel's arithmetic sequence. So the general term just keeps the value of N in the sequence. So for Joel, we have Tn equals A plus D times N minus 1. I'm going to keep this as Tn. A is 6. Our common difference is 15. And I'm going to keep the N minus 1 in there. So if I multiply my 15 through the brackets here, just to simplify this, I get 6 plus 15N minus 15. So that's going to equal 15N, and then 6. Take away 15 is negative 9. So this is what we call our general term. So Tn. That's our general term. For Jenna, same idea. Tn equals A plus D times N minus 1. I plug in everything I know except for the N value. A is 21 this time. Our common difference is 15. I'm going to keep that N minus 1 there. I'm going to multiply that 15 through the brackets still again. And I get Tn equals 21 plus 15N minus 15. And this time we're given 15N plus 6. So this is our general term for Jenna. Looking at D, explain why the formulas in B and C are different. The reason why is because different values for the first term will lead to different values of N when solving a specific problem. So different values for T1 or A will give different values of N. Part E, if the tree continues to grow at the same rate, in which year will it reach a height of 28 feet? So using Joel's method, I've got 28 feet. I need to change that into inches. So I need to multiply that by 12, which is going to give me 336 inches. So for Joel, using our, just up here, using our general term for Joel, Tn equals 15n minus 9. instead of Tn, I'm going to plug in that 336. So 336 is going to equal 15n minus 9. Let's add 9 to both sides here. So we get 345 equals 15n. Dividing both sides by 15 gives us a value of n equals 23. So for Joel, if n equals 1 is the year 2000, June 2000, then n equals 23 will occur in 2022. Let's check that for Jenna as well. So for Jenna, again, her general term is Tn equals 15n plus 6. Again, we're going to plug in that 336 in for Tn and then solve for n. So let's subtract 6 from both sides here. So we get 330 equals 15n. If I divide 15 from both sides, I get n equals 22 for Jenna. So for Jenna, she said that her n equals 1 occurred in 2001. So her n equals 22 also occurs in 2022. Same answer. So the answer for both of these, depending on which method you used, gave us the same answer, 2022. Generating number patterns exhibiting arithmetic decay. So decay means we're getting smaller this time. Many real-life scenarios can be represented by a pattern of numbers which exhibit arithmetic decay or arithmetic depreciation. So example number 2 starts out with a printing press. A printing press was bought in the year 1992. It depreciates in value by the same amount each year. 5 years after it was bought, the printing press had a value of $311,000. It had a scrap value of $2,900 in the year 2010. Use an arithmetic sequence to determine the amount of the annual depreciation. So how much is it going down per year? So basically, we're trying to find the value of D, what it's depreciating by. All right, so let's start by letting Tn equal the value n years after 1992. So 5 years after the printing press was bought, it was worth $311,000. So that's term 5. In 2010, that was 18 years after 1992, so term 18, that's going to be equal to $2,900. So 18 years later. So if I look at term 5 and I write this out in terms of our general term, I don't know what A is, and I don't know what D is, but I do know that the n value here is 5. So instead of this n value right here, I'm going to put in 5 minus 1. So I have $311,000. That's equal to A plus 5 minus 1 is 4D. On the other side, I've got A plus D times, I don't know what D or A are, but I do know that n is 18. So 18 minus 1 is going to go in there. And I get 2,900 is equal to A plus 17D. So now I've got 2 equations and 2 unknowns. So I can use substitution or elimination in order to solve these 2 equations, just like we learned from grade 10. So if I put these 2 equations together, I'm just going to bring this one down here. I'm going to have 2,900 equals A plus 17D. If I subtract these 2 equations, I end up with, let's see, 311,000 minus 2,900 gives us 308,100. And then the A's will subtract to give us 0, so that cancels out. 4 minus 17 is negative 13D. So then to solve for D here, I'm going to divide both sides by negative 13. And that leaves us with a D value of negative $23,700. So that means that the annual depreciation is equal to $23,700. So we're losing $23,700 every year, essentially. Part B, determine the purchase price of the printing press. All right, so basically this time I want to find the value of a. So I can use either of those two equations I had at the start. So I've got a plus 4d equals $311,000. I can use that one. Or if you wanted, you could use a plus 17d equals $2,900. Either one should work. What we're going to do next is we're going to plug in the value that we calculated for d up above. So inside here for d, we're going to put in that negative 23,700 number. So we get a plus 4 times negative 23,700 equals 311,000. If you plug that into your calculator, you get a minus 94,800 equals 311,000. Adding that 94,800 to both sides gives us a value of $405,800. So our total value, our T1 value, or A value, at the end of year 1 is, so at the beginning of that year, it was initially bought for $405,800 plus that $23,700 that depreciated in that very first year. So the total value of the initial amount is $429,500. And finally, example 3, relating arithmetic sequences to linear functions. So we can relate arithmetic sequences to linear functions over the natural numbers. So natural numbers are those numbers that are entire numbers, 1, 2, 3, 4, 5, etc. They're only positive. They don't include 0. They don't include negatives. They don't include fractions or decimals as well. Consider the following example. A pile of bricks is arranged in rows. There are 28 bricks in the first row, and the number of bricks in each row is 2 more than in the previous row. So our D value is going to be 2, and our A value is going to be 28, or our T1 value, if you like. Part A says, complete the table of values showing the number of bricks in each of the first 10 rows. So row number 1, we have 28 bricks. Row number 2, we'd have 2 more, so 30 bricks. 3, we have 32 bricks, etc. All right, so if I plot those ordered pairs on the grid, I'm starting at 1 and I'm going up to 28, so right about here. 2 is 30, 3, 32. Or the dots here do go up in a straight line, so if I did connect the dots, they would all be joined together in a straight line, which makes it a linear relationship. So linear just means straight line. Nonlinear would be curving. Part C, determine if the range is an arithmetic sequence. So the range is the value of y up and down. Is the range an arithmetic sequence? It is. The range is an arithmetic sequence with the first term equaling 28, so A equals 28, and the difference is 2. It goes up by 2 every time. So that would be yes. Part D. State the domain of the relationship. So the domain is talking about the x values this way. So the x values are the set of natural numbers. So we don't go into the negatives. We don't include 0. So it is the set of natural numbers. And in this case, it's only basically from 1 to 10, up to 10. Part E, why does the graph not have an intercept on the vertical axis? The reason why it does not have an intercept on this vertical axis here is because that is where r equals 0, and we can't have a 0 row. So we can't have row 0, essentially. And part F, write the equation for the number of bricks in a row, n, as a function of the row number, r. All right, so this is like our general term. Tn equals a plus d times n minus 1. In this case, our Tn value is the value, which is just going to be our n value from here, so the number of rows we've got. Our a value is 28, because that's the total number of bricks in the first row. The d value is 2, because we add 2 bricks for every row. And then we have, r minus 1 in here. R minus 1. So if I simplify this, I get n equals 28 plus 2r minus 2. Simplifying that gives me 26 plus 2r as our final answer.